Okay, we are having another question here in a turnable arrangement shown in this figure below. Block A, okay, here hapa block A ina mass ya 0.9 kilograms and block B ina mass ya 1.7. The blocks are 13 centimeter from the axis of rotation. 13 centimeter from axis of rotation. The coefficient of static friction between the blocks and between the blocks A na B na between the blocks na turnable, okay, manake B alipo na turnable is 0.1. Okay, so remember kwamba you are having this arrangement here. So hii ni platform kwa kama alivyoisimplify hapa. This platform is rotating going there. Okay, so you are having those bodies connected and they are moving going there. So consider the friction and the mass of pulley as negligible. Find the angular speed of rotation of the turnable for which the blocks just begin to slide. So first thing is to understand this motion. So this, as I said, ziko hapo and it is moving. So what is happening, kwa tukiangalia kwa mfano hii side view. Okay? So hapa anakuambia kwamba everything depends on correctly predicting direction of friction force between A and B. So we expect due to this motion, okay, due to this motion, these bodies zina face radial, okay, so nakumbuka zina centripetal acceleration, okay, that is acting towards the center. So eventually they will experience a radial acceleration and therefore they will be moving taratibu. As this is moving around that, they will be moving also linearly outward, okay, especially this bigger body ambayo ina more weight ndio itakuwa inafuata the bigger effect kwamba ita move pembeni. Kwa hiyo italazimika kuwa as this is moving inalazimika kwenda hivi, and aka kama SB as a result kama ina move hivi, hii string inakuwa ina pull in the opposite direction. And therefore as far as this pulley is concerned, tuna depend on these tensions kama torque. Na inakuwa namna hiyo. So the second step is to form equations depending na specifically, okay, depending na specifically the bodies themselves, okay, depending on specifically the bodies themselves. So we start with the first body, okay. So the first body A is moving inside kwa sababu the body B is pushed, inapata radial acceleration outward, inalazimika kwenda outward and more, since it is ina more weight inamlazimisha huyu sasa amvute kwenda ndani. So as this is moving ndani, kuna friction between A and B, okay. So assume the body B is stationary anyway, so this itakuwa ina experience a friction force opposite. Kumbuka the tension is the one that is pulling it over. So the net forces kwenye A, the driving force itakuwa ni tension, okay, the driving force itakuwa ni tension minus the friction force F due to A. Okay, we can call it F ambayo ndo friction between A and B. Kwa utakuwa T minus F linapata mass ya A times acceleration. So tuna T minus F ni sasa mass ya A times acceleration. So hapa amesha convert, okay, amesha convert kwamba the acceleration, okay, ni sawa na tumesema kwamba mass times acceleration ni sawa na alpha times radius, okay, alpha times radius, ambao also acceleration ni sawa na u squared times r. Okay, either way zote hizi ni expressions acceleration, so either you put alpha times r or you leave it w squared times r, zote ni expressions acceleration. But the point you should understand me ninachokisema jinsi tunavyoform equations. Equation 1 is done for body A. For body B it is moving that way. So ina experience two issues here, okay. Ina experience, okay, ina experience tension ambayo iko opposite, tension ambayo inaelekea huko, the tension. Lakini kuna friction hapa chini due to B na turnable. Because this body is moving huku, there is friction ambayo is moving in the opposite. So kuna friction pia ina move in that direction. Lakini kuna friction nyingine ambayo inatokana na body A. So as this is moving here, body A anamtengenezea friction ya kumoppose. Kwa hiyo ana friction nyingine hapa. Kwa ana friction due to A na friction due to turnable na tension. Kwa in total the tension plus the, as you can see, these are the forces acting on body B. Okay, we have the tension, we have the friction force ambayo ni due to the turnable, and we have the friction force due to body A. Kwa tension, friction force, the friction force due to the turnable ni sawa na body A times acceleration. Kumbuka acceleration as I said ni R times alpha au R times W squared, zote zinakupa acceleration. Don't worry about it. And so tayari tuna equations mbili za swali letu. The question here linatuambia tutafute angular speed of rotation, and it's the reason why anyway wameamua kuja kuiweka in terms of this ili tusihangaike kwenda mbali. So tukisolve sasa hapa tuangalie what do we have. Hatuna tension. Okay, we have the friction forces, because friction force tunajua ni sawa na coefficient of friction times normal reaction. So friction force between A and B, okay, friction force between A and B itakuwa ni sawa na coefficient of friction times normal reaction. So you can see, okay, you can see that the normal reaction hapa ni weight ya A. Okay, so friction force between A and B is as a result of normal reaction due to A. Kwa hiyo maana yake friction force F, EF itakuwa sawa na coefficient of friction times weight of A, while friction force F dash due to the arrangement na the turnable ni sawa na coefficient of friction times the normal reaction, ambayo normal reaction ni weight tu, sio tu ya B bali na A ana contribute to weight yake. Kwa weight A plus weight B. Kwa hiyo you can see F dash ni. So it means tuna coefficient of friction na tuna weight za hizo two blocks. So we can say we have F, we have F dash, we have F. So we have the tension ambayo ni unknown. Okay, the masses are known, the radius is known, and therefore we have the radius ambayo tumepewa ni hapa 13 cm. And labda swali lako liwe unajiuliza, okay, so why are we using this radius? Kwa tunatumia this radius and not of the pulley kwa sababu remember acceleration ambao wana experience hawa ni radial acceleration. Okay, ni radial acceleration ambayo ina depend na hii movement. Kwa ni centripetal acceleration. Okay, ambayo ni alpha times the radius of the cycle hii ambao watakuwa na move nayo, and not the pulley. Okay, so that the radius tunaoongelea ni hii, because the acceleration tunaoongelea ni movement ya these bodies radially ambayo it is as a result of centripetal acceleration. So here what is unknown is W na tension. So if we have two equations, two unknowns, we can solve for the equations and we can get W ni sawa na 6.4 radians, and therefore the question ambayo ilikuwa inauliza find the angular speed of the turnable, we can get it in that way. So kwa kufanya hivyo tutakuwa tumepata our question, and remember this is for W max. You remember, labda niongee tu point as to why hapa kwenye acceleration tumetumia R times W squared. So you remember kwamba circular motion is another version of simple harmonic motion. Okay, circular motion is another version of simple harmonic motion. And you remember kwenye simple harmonic motion tulikuwa tunasema kwamba the acceleration sasa na W squared times x. Okay, W squared times x, where x is the displacement, okay, from the mean position, and therefore our mean position is the center of the cycle, and we have the displacement as the radius of that cycle, and therefore this is another expression of acceleration, and therefore we can use this to solve our question. So do not confuse now what was happening here. what was happening here is totally different. Okay, here we are having bodies that are having radial acceleration. Here the acceleration was not radial acceleration. These bodies were just moving as a result of the pulling. Tofauti na if these bodies zingekuwa zina undergo circular motion. Here the bodies are not undergoing circular motion. Zinaenda juu, zinashuka chini, zinashuka juu. But here the body is undergoing circular motion, and therefore we are considering radial acceleration. Here the bodies are not undergoing circular motion. Okay, the bodies are not undergoing circular motion. So get it clear. And therefore the acceleration tulikuwa tunatumia ilikuwa ni we are left kutumia na alpha times radius. Lakini huku kwa vile this acceleration was radial acceleration, then tuna chance ya kutumia simple harmonic motion ambayo inatuambia acceleration is w squared times x. We have as shown in figure here, a girl on a rotating platform and hold a pendulum in her hand. Okay, a girl on a rotating platform holds a pendulum in her hand. The pendulum is at radius, okay, of 6 meters from the center of platform, and rotating at the rotational speed of the platform is 0.02 revolutions per second. It is found that the pendulum hangs at an angle of theta to the vertical as shown there. So find the angle theta. So it says the external forces on the pendulum are shown in the figure. So hiyo pendulum as far as inakuwa ina swing hivyo, kwa kunakuwa ina tension na ina weight. Okay, so here we have tension. Look at this angle ni sawa na ikiwa hapa. For tension, okay, tension cos theta, and we are having here tension sin theta. And therefore, it can be written that T sin theta ni sawa na mw squared over r. Nilikwambia sehemu zote ambazo zina involve radial acceleration kwa sababu ndo centripetal acceleration. So it means katika hiyo motion hii T sin theta ndio ina point inwards, ndio inasababisha centripetal acceleration. So T sin theta ni sawa na centripetal acceleration ambayo ni mv squared over r. Kwa ukisubstitute ukichange kwenye w, hii ni sawa na m over r, v squared ni sawa na w squared r squared. Kwa r inakufa, kuna baki na w squared r. Kwa t sin theta ni sawa na m w squared over r. Okay, mw squared over r. So tunaendelea kwamba t cos theta minus mg ni sawa na 0. So at that point, because the body is not moving in up, so these forces will balance. T cos theta na mg will balance. So t cos theta ni sawa na mg, the weight. Okay, yes. So if we solve here for the angle, okay, if we solve here, we can divide the equation na tunapata tan theta ni sawa na mass na cancel, w squared r over g. Okay, so we have w, tumeambiwa rotational speed of the platform is 0.02 revolutions per second. So we multiply na 2 pi, tunaziconvert kwenye radians per second. Radius tumeambiwa ni 6 meters from the center. We have g, and therefore tan inverse tunaweza tukapata angle, okay, ni 0.55. Again we are having a 20 milligram bag sits on the smooth edge of a 25 radius phonograph record. So we have phonograph record na kabag kama sit hapo 25 radius, okay, 25 centimeter radius, and is brought up to its normal rotation speed of 45 revolutions per minute. How large must be the coefficient of friction between the bag and the record be if the bag is not to slip? It means, kumbuka wakati tuna move hivi, the bag is experiencing radial movement, anaenda outward. Okay, kumbuka kama tulivyofanya in this question. Okay, in this question ambao kulikuwa na radial acceleration, you remember this question, okay? So the masses were moving outward. Kwa napata radial acceleration outward, the bag is facing radial acceleration outwards. So it means acceleration yake outward lazima iwe sawa na friction force. Okay, acceleration yake outward lazima iwe sawasawa na friction force so that the bag does not slip. Kwa kama hiyo iko hivyo, the bag is moving radially outward. Okay, the bag is moving radially outward and therefore inapata radial acceleration outward, na huku ndani kuna friction force and experience. Okay, so it means that the bag won't slip off kwa sababu anapata radial acceleration. Okay, so manake radial acceleration lazima iwe sawasawa na friction, because however ana accelerate, centripetal force ina mpull ndani, lakini the bag anakuwa na oppose, so anakuwa the radial acceleration inakuwa ni sawasawa na friction force. Okay, the radial acceleration inakuwa sawasawa na friction force. So you equate the two. The radial acceleration, as I said, kwamba hii ni mass times centripetal force. Kwa mass times acceleration, mass times centripetal acceleration ni sawasawa na ikiandikwa mass w squared r. Okay, so the friction force ambao ni sawasawa na normal reaction times coefficient of friction. You know, the friction, the normal reaction times coefficient of friction force. So ni sawasawa na normal reaction ambayo ni weight ya bag, kwa ni coefficient of friction times weight ya bag, na equate na mw squared r. The question inasema how large must coefficient of friction be, also for that m na m ina cancel, unabaki na w squared r divided by g. W squared tayari unayo ambayo ni normal rotational speed iko hapo, times the radius ambayo ipo, the radius umepewa ni 25 cm. You put in the numbers na you finally get your answer as 0.566. So as far as the section ya torque is concerned, we are done with so here we are having additional questions for your own practice. You can do this on your own. Okay, to practice this. This is a solid cylinder of mass 20 kilograms rotates about its axis with an angular speed of 100. The radius of the cylinder is that. What is the kinetic energy associated with the rotation? It's just simple. Okay, you know it is half IW squared. So put in the numbers and you get the answer. What is the magnitude of angular momentum about its axis? Just simple. IW. We have everything here. The angular speed umeshapewa, Mungu akupe nini maskini. And we are having the mass, we are having the radius, so just put in the numbers. Another question, kwa mfano hapa, a child stands at the center of turnable with his two arms outstretched. You remember kule tulikuwa tunafanya skater, tumefanya professor. The turnable is set rotating at an angle of 40. How much is the angular speed of the child if he folds his hands back and therefore reduces the moment of inertia to 2/5 times the initial value? So kumbuka kwenye swali la professor lile tulilofanya. So I want you to try this and get these answers. Okay, fanya hili swali upate hili jibu, fanya hili swali upate hili jibu. Ni kama tulivyofanya kwenye swali la professor, amebeba dumbbells. And here we are having a rope of negligible mass. It is wound around the whole cylinder of PU and radius 40. What is the angular acceleration of the cylinder if the rope is pulled with the force of that? Basi we know mambo ya torque. So that kwamba torque ni sana angular moment of inertia times angular acceleration. So tumesha, so swali linatuambia tafute angular acceleration. So we have the torque, tumeshaambiwa kwamba it is pulled na force ya 30 Newton. So moment of inertia hii ni a hollow cylinder, so m squared. So we have everything, we put in the numbers, tunapata angular acceleration. So linear acceleration tuna multiply tu na the radius. Okay, tunapata linear acceleration. And the final question here, we are having a motor. Okay, we are having a motor at a uniform angular speed of that. An engine needs to transmit a torque of that. What is the power required by the engine? Okay, note uniform angular velocity in the absence of friction implies zero torque. So in practice, applied torque is needed to counter the friction force. So it is just that simple. The energy ni sawasawa na torque times distance. Force times distance is the what causes the energy. So wanavyoongelea power, we know energy over time ni power. Okay, so over time, so make power ni sawa na torque times theta over t, as you can see in angular velocity. So angular velocity times torque unapata power. So we have torque ambao ni 180, okay, and we have the angular velocity ambao ni 200. Okay, so no friction force, ukipata hapo unapata all the power inakuwa, it is that simple. So put in the numbers and get the answer. We have further problems of practice, so you can do this on your own. Here we have this bunch, so practice this. So here we are, books to use. Make sure from here you pass through all advanced related questions, solve as many as you can in advanced physics review, in Nelcon and Rogers, which are perfect for mechanics as always. Don't forget S-chans, don't forget the applications, the definitions, the conceptual questions at the end of the chapter, ili usiache max hata moja. So make sure you pass through all this, and so we are having a new format. So you are supposed to do all questions, so it contributes 10 marks in whatever question you could stay. So you need to leave these 3 marks, and I hope we wish you the best. Stay tuned for our next lesson. Please don't forget to subscribe.